So, without further ado, I'd like to, excuse me, I'm sorry, introduce our first speaker. Thomas Holm is a representative. Thank you for taking that away. Or did I do that? Okay, that's good. Okay. Never mind. You can go ahead. I'll just read off my cheat sheet. Okay, Thomas Holm is he's with the Namur committee member. He's also employed by WAGO in Germany. And please join me in welcoming Thomas Holm to the panel.
Thank you, Dick, for the warm welcome. And also welcome from my side to you. What I'm presenting is an approach of NAMO and Z4E. I don't know if you know the NAMO. It's an interesting committee of the European process and pharma industry, and additionally the Z4E is the other side of that's the vendor group, and these groups together working out a very interesting approach for modular process plants. Yeah, we heard a lot about IoT and Industry 4.0, as we know this IIoT thing in Germany. I don't want to bother you with some deeper details. Just let me point out some main facts. We have still real-time capability also in Industry 4.0 and IIoT. It's not a thing we can change just by using IoT. We have still we will have the service orientation, which shows that cyber physical systems and humans or plants can offering services via the Internet of Service. We have a harder decentralization. We don't have these monolithic automation system anymore. And we have a deeper interoperability, or we will have a deeper interoperability between the cyber physical systems and humans and plants. The robotic human interconnection will be much deeper than today. And we will have the virtualization. The digital twin is often used word in this area. And we will have for sure more modular production, but modular is actually not a new approach, it's a quite old approach. The IT industry using modularization a long time ago in the PCs and so on. And but my focus is on these two topics. What about modularization, modular production, and decentralization in the process industry? And for me, these two aspects are some key element for Industry 4.0 and IIoT. Yeah, what is the idea actually about modular productions? As I understand it, and as the NAMO and Z4E understand it, a module offers a specific functionality like a process function or the unit operation, and that is actually, as I understood it, the main difference between the open automation activities here in US. And the whole process arises then when I put different modules in a row or parallel, and so I have then the unit operation I need to produce the required product. Every module has to include its own intelligence. Why, or what is the reason behind? I will show later. And the modules are coupled on a backbone, on the infrastructure. And this infrastructure feeds the modules with the required utilities like CO2 or vacuum and so on. And also the backbone includes the process control layer. And when you struggle now and say what is actually what is the process control layer, we are used this word on purpose, that is not put you some picture in mind. We don't want to use the word DCS here. We don't want to use the word MEC here or ERP system. What is here inside the infrastructure could be something totally new. And the challenge is then, because the time is counting, that the quick reassembling and modeling of the automation system in the process control layer is always like the physical world. And this should be done without any programming and following the idea of plug and produce. But how to do this? How to integrate modules in a PCL layer that's fast? We needed it. For this, we need somehow a skill description. What is this module about? What is actually the service which comes from the module? And so this skill description has to consist the description of the function of the modules of the module, the information for visualization, the HMI of a module. Somehow here in the process control layer, there's still an operator working, and this operator needs an HMI. We need information about the communication technology and the communication between the process control layer and the controller inside the module, and we have to provide some documentation about the module and information about an opportunity to parameterize important field devices inside of the module. Yeah, and this is what the story is about. We modeled this skill description and we named this module type package. And this module type package includes all this information. And we have done some step more. We modeled the communication not on the variables, not on the data, but we encapsulated this, the functionality of the module as a service, and this module is offering the service, and the process control layer then can execute this service. Let's have a look on the workflow. What is about the engineering concept about behind MTP? When you work out a process plant with modules, you have typically two engineering phases. One, which is timely in front, is a phase where you compile and when you plan and you build the module. And another, on the second step, you take the module and you want to integrate this module in an infrastructure. And these two phases are binded together by using the MTP file. And in optimal case, this MTP file is generated automatically. So where to get the information about this skill description and the MTP content? When you look deeper inside the information which you need in this engineering phase, you will come that this information is already existing here, and especially inside the program code of the module. So what we have done is we are parsing the program code of the controller and looking for some patterns and taking out this information and modeling this information inside the MTP file. And as this MTP is deeply connected to the program code, when you change then the program code, you have to generate a new MTP file. So there's a one-to-one connection between the module and the MTP file. How did it start? In 2014, we presented this approach at the NAMO fair, and in January of the next year, in 2015, the NAMO decided to follow this MTP approach, and to work out deeper specification and standardization inside the NAMUR. In February 2015, we formatted different working group inside the NAMUR, which has the task to work out the content and the syntax of the NAMUR MTP. What is done so far is that we work now on 7 NAMUR working groups. Currently, more than 25 companies are involved in the activities, and we cut the whole task, the main task of describing a process module into slides, and there's a slide of HMI, which is worked out by the NAMUR working group 291. We have the state-based control, which content is working out by the working group 2.3, and we have a technology workshop which handles all the modeling questions, and we have also a standardization group inside the VDE, which is currently working out a specification for the content and the syntax of an MTP file. These are the companies which are involved in the specification, and as you see here, the DCS manufacturer are nearly the same as in the open automation activities. And we have also a big pull by the end users that is nice, and that pushes the activities very hard. So we are quite far, because in November 2015 we could present the first, let's say, theoretical results, and in 2016 and at the NAMO fair 3 months ago, we could demonstrate a workflow that shows that one vendor is generating an MTP file, and another vendor, for example, a DCS vendor, could read in the MTP file and could communicate with the vendor where the MTP file where the MTP file comes from. And we worked out also the first draft for an international specification, and as you see here, from 2014 to 2016, only 2 years, and I will show you now that it really works. And what is actually inside an MTP file? I have shown you here a print screen of an MTP file. It's right now a zip file, and the zip file contains different XML-based files modeled in Automation ML. Automation ML is an IEC standard, and this includes the manifest, and the manifest defines the communication protocol, which of what the module is speaking. It defines the path to the services which are offered by the module. It defines the path to the visualizations of the HMIs, and it defines also, or we decided that the preferred communication is OPC UA. This is a view of the demonstrator at the NAMO fair. So you can see here some vendors. No, it's not working on the left side. You can see some vendors are designed MTP files, and then we could decide which DCS imports the MTP file on, and then suddenly the HMI is generated, and the values of the different variables can be shown. We as WAGO did this also on the NAMUR at the SPS EPC Drives Fair, and we showed that the MTP file could be automatically generated out of an engineering tool, And that it is possible to read in a totally new module, like for example a package unit, can be done by 2 minutes 30 seconds. I will show you now on this video. This video has two parts. First, the module engineering, and then the reading in of a module. This is the engineering tool of the controller inside the module, and as the module needs some program code, this program code has to be designed in the phase of the module engineering. That are the typical behavior of program code. We defined a library which includes all the requirements we are looking in, and this is the part where the program code is connected to the visualization. So also the controller of the module includes a small visualization which could be shown in the local panel. And this is actually the program code we generate the MTP file in. This is the program code at the ready state. Everything is there. The sequences, the equipment specific function blocks. And also the HMI is in there. And what I will do now is I will generate an MTP file out of this. And this is done by an additional algorithm which is also included in the engineering software. And this is the HMI I'm choosing, and these are the services which are inside the program code. And at this step, the module is binded and it is saved at the local machine. Now the process production plan can be made, and this is the state where the MTP file is read in, and I've chosen this, and now all the variables are included, all the HMIs are mapped, and the services are modeled as phases inside the batch system. The only manual step is I have to add the IP address to the OPC UA driver, and when it's done, I can start the runtime and everything is fine, and I can use the controller as it is the controller of the vendor. Now the runtime will start. There it is. First check in and the runtime, and these are automatically generated HMI pictures. Totally come out of the MTP specification. Nothing manual inside. Also the sensors and actuators are on, and the batch system can be added now with the phase of the needed service. Here's a list of service which are read in. There's the filter, and the service is filtering. And now it's put in the recipe, and there's also the opportunity to add or model different parameters. And so the process plan can be started by executing the recipe. And now the production plan works. With a totally new module, the DCS system has never seen this module or this vendor before. It's only described by the MTP file. Yeah, this is 15 minutes of MTP. Normally it takes me 1 day to bring interested persons inside this technology. I know that there are some questions, like always. But we can talk about later. Thank you.